beginning. So my name is Nico Freitag. I work here at TechnologyCatalogue.com in business development, and I will act as somewhat of a host or moderator for the day. And just to start things off very quickly, some basics. Regarding the interaction, I would like you to address your questions to the chat box at the right. We will address those questions at the end of this presentation. Regarding content, that's a common question. Yes, materials will be provided in a wrap-up email by us that will be provided shortly after this webinar. And thirdly, where to find the technologies, so Cerebra on our platform. That also kind of segues us already into the agenda. It's very straightforward. I will quickly show where to find Cerebra on our platform. Then we're going to enjoy a presentation really quickly and have the Q&A afterwards. And I hope we get to all the questions. It's not a hard stop, but please be assured that we will answer all your questions, and you can always reach out to us afterwards. And with that, I will just quickly show this. So Cerebra can be found under the oil and gas schedule if you select your industry at the bottom left. Or if you know what you're looking for, you can also use the search mask at the top. But let's say I was supposed to click on oil and gas. It would bring me to the next one, which is the subcategories. And we're looking at digitalization. So we're clicking there. And to quickly find Cerebra, I would choose the filters digitalization and maintenance. If I want to browse a bit, this is where I found it. But if I know what I want exactly, I just search it at the top and type in Cerebra or Flutura. And it will bring me directly to the page. And this is how the page looks. So this is a great example of it. In red, you see a quick overview of what the company is about. Just below that rests the pro and cons list, in green highlighted here. And next to it, you can contact Flutura directly through a chat box or via phone call. All the information are given there. And if you want to know a bit more, you can simply scroll down and there will be more details provided. In red, you see specifications. Just below that in green are resting the relative business impact and the technology readiness level. And also, not too unimportant, you can also see who's already deployed this technology. And you can ask, so you can send a request to Flutura as well to ask who else has reviewed this. They will be, I'm sure, happy to engage with you on that. But that's really everything from my side. I want to keep this very, very short intentionally. And it's my great pleasure to have you here today, Ramesh Nair. You're the VP in Strategy Consulting at Industry Solutions. And I'm very much looking forward to your presentation today. Good to have you.
Thanks, Nico. I hope you can hear me clear, loud. Okay. Yeah. Good morning, good afternoon. I see people joining in. So I hope you're all doing good, healthy, and safe. I know it's uncertain times. So I'd like to thank Nico and Sophia from TechnologyCatalogue for hosting this session and giving me an opportunity to present our viewpoint on and the learnings from the digital twin project that we have done. Just quickly run you through a short presentation, and then we have question and answer sessions at the end of it. And then we have some poll questions that will come up during the session. Let me just start the presentation. So this picture was from a report that McKinsey published in September 2020 about the digital initiatives within the energy companies. And they had this image of a white whale up there. And the report says for the energy companies, achieving value from digital technology has become like a white whale, which is anxiously hunted, dimly perceived, enormous but elusive. So this 4 characteristics actually sums up most of the digital transformation projects that we have seen. Anxiously hunted, dimly perceived, enormous but elusive. So we have seen most of the companies embarking on these projects, running pilots, process digitalization, automation, but still the value is something which has been elusive. But if you look at the current circumstances that most of this industry goes, people talk about new normal and all that, but this is the era of nothing is normal. Okay, we don't have the luxury to embark on projects where it actually fails to deliver value. Most of our companies are faced with a great deal of demand destruction, price volatility, a lot of discussions around transition to a low carbon environment and all that. So the industry is talking not about high growth and all of that. This is talking about the basic sustenance of the industry. But the good thing that we have observed in this crisis is that the silver lining of this crisis is that the barriers for change has dropped dramatically. Digital is considered to be a must-have for sustenance within this organization. And like I tell my customers, never let a good crisis go to waste. There has been no better time to invest in digital transformation than the current times. So with that, I'll just get into the presentation and introduce our company. We are Flutura. We are a verticalized oil and gas company focusing on oil and gas process chemicals and OEMs. And our promise to the market is to deliver operational intelligence for people who take decisions on the trenches, on your gas fields, on your factories, on your oil and gas fields. How to enable them with tools of data analytics and AI so that they can make better decisions in a very cost-effective manner at a faster pace. And our customers, you can see our customers lined up on the bottom of that slide. They have entrusted us with their toughest operational challenges, and we have delivered each one of them for our customers. And they being our customer is the greatest testimonial of the value that we have delivered to the industry. Today, before we go into the details of the project, I would like to give you a heads up. Swati, who is my colleague on this call, will be posting some of the poll questions just to take the feedback from the participants. So, Swati, can we have the first question, polling question, please?
You can find it under polls. It should be published. So I see people are voting for it. So yes, perfect. People are finding it.
Yes, Swati, probably we'll give a couple of seconds and then move forward. Okay, go back to the slides. Do you want to quickly flash the results, Swati? I don't know how much of an effort or time it is.
Hey, Ramesh, I had opted for it. I thought it would be displayed
Okay.
now. But...
Okay, that's fine. Let's move on.
Okay.
So today we are looking at a large gathering system that we work with a large oil and gas major. So as you understand, these are large, complex system of systems that play out. The field that we were working is around 500,000 acres of land, 300 dry gas wells, 80 well pads, 150 miles of pipeline, 25 compressors and dehydrates lined up, which feeds to 7 sales points. So from this itself, you can comprehend the complexity of decision making in these kind of gas fields. And the optimization of a gas gathering system has become a kind of an operational necessity in the current circumstances, where the price sensitive market and each gas well or an oil well is like a cash machine. So you don't want them to go down, but you don't want to incur too much cost that will offset your profit volumes. So you have to operate it under tight operating conditions, tight cost context, and ensure that it meets the demand of the sales contracts that you have. So there are concepts like minimum volume commitment that you roll out to your midstream partners. So you need to match that sales point minimum volume commitment to avoid any kind of a penalty. You have to maintain the operating conditions so that it's safe to operate that field. You need to maintain the integrity and the reliability of the equipment across your platform, across your gas gathering line, so that you can ensure production. So field operators and production engineers are tasked with a series of high impact decisions that they need to take on an hourly basis, on a daily basis, and on a monthly basis. These are about your contractual criteria, to reduce your production deferments, to optimize the maintenance of your equipment, to identify the bottlenecks across your networks, and to assess the well condition. So these decisions have a higher bearing on your revenue or your cost and your safety. So when this customer asked us to look at the optimization of the gathering field, the first question that we asked ourselves and even the field operators is that, how can we improve the quality of decision making on the field? So we took an inventory of how many decisions on an average a field engineer takes in a gas gathering network, and how can we help them to improve the reliability of decisions, or rather the accuracy of the decisions. What kind of a cost is incurred in decision making? Can we reduce the cost of decision making? And the third element that we looked at was, how can we improve the speed of decision making? In most of these cases, the speed matters, because if you can take an intervention on a compressor that is likely to go down much ahead in time, that you are protecting the production volumes, you are minimizing the deferment, and you are reducing the maintenance cost for that equipment. So it all boiled down to three things. How can I improve the accuracy or the reliability of the decisions that field operators take? Second was about, how do we reduce the cost of decision making? And the third was about, how can I increase the speed of decision making cycles? Okay. With that, Swati, can we pop up the second poll, please? Okay. Okay. Can we go ahead, Swati? Okay. Right. I see a lot of interest on the predictive maintenance side. So moving forward, 300 plus wells, 80 well pads, 25 compressors and dehydrate stations, 7 sales points, and 150 miles of pipeline. So in this field, they had an existing system landscape of SCADA and historian systems aggregating data. And the operators have configured a series of alerts, which are based on straightforward rules to manage any kind of unexpected event. But most of these alerts were configured for individual equipment and was creating a kind of a situation called the alarm flooding, where there are too many alarms that are popping up for the operator to keep track of. And it was humanly impossible for a field operator to go through all these individual alarms and take decisions based on that. The second one was the series of high impact decisions that the operator was making, like a compressor was going out of lease. And they were posed with questions that, should I renew it or should I opt for a compressor with a lesser capacity? Because all this will have a bearing on cost. All this will have a bearing on production deferment or operational integrity. So these questions were asked often to the field operators. Or are we not going to meet the minimum committed volume at a sales point if you reconfigure the well to manage an issue on a well pad and reconfigure the network to direct the flow from, say, sales point 1 to sales point 2? So this created these kind of alert, and the operational systems actually could not give too much of a visibility on the current state of network, or even the advanced view of events that can result in a potential shutdown of a well or a network. Secondly, the current systems were not equipped to provide this kind of a scenario modeling to configure your what-if scenarios for high-impact decisions. The third was they had simulation tools, but as the field was growing and new wells were added into the field, the simulation models were not able to cope up with the changes in the operating conditions. So these models became out of date. So basing your high-impact decisions on a model that is not updated caused a certain operational risk and a safety risk for the operators. So it was cumbersome to run these simulation models as well. So this resulted in operators relying mostly around their experiential knowledge and rules of thumb to make these high-impact decisions. So what we did here was to frame up our problem statement around 3 dimensions. One was, how can we provide situational awareness to the field engineer on the current state of the network? Okay, rather than looking through a series of alarms and then taking calls, can we provide them an easy-to-use interface so that situational awareness of the current state of the network is available to them? The second was, can we configure a series of advanced anomaly detection, both at the well pad level, well pad level, and at the gathering system levels, so that we can identify an early warning signals or symptoms of an event that is cropping up on your network well before it actually comes in. The third was to enhance the decision support for the field engineers by providing a easy-to-use what-if tool, which sits on top of your existing simulation tools, but enhances that simulation tool using a data-oriented or an ML learning, machine learning-based algorithms on top of it. So this is how we approach the project. So we broke it down into 2 phases. So we broke the project into 2 different phases. One for the field engineers to get the situational awareness, and phase 2 was to build a hybrid machine learning model to take all these what-if scenarios into consideration. So in phase 1, we built what we call as a network digital twin, which maps the complexity of your entire gathering system network, along with all the subsystems, which includes your dehyde units, your valves, your meters, your compressors, everything into what we call as Cerebra digital twin workbench, with the constructs like universal machine model and universal process models running behind the scenes. Second, we connected this digital twin towards the data flow from the historian on a real-time basis. And we configured the diagnostics packages both at the well level, well pad level, and even at the equipment level through Cerebra's proprietary diagnostics package to detect anomalies. So what value did it bring to the field engineers? Earlier, field engineers were looking at a series of alarms to make decisions. Now, the digital twin configuration pops up on a screen, which gives you a clear view on what are the events that are happening across your network. What's the current state of the production? How much gas are we transferring to individual sales points? Is there a drop in volume? Is there a liquid loading issue that he is seeing on the well side? what interventions that he needs to take. So it just focused field engineer's attention to the actions that he needs to take rather than going through a bunch of alarms and then kind of figuring out what needs to be done. So this actually reduced the cost of decision making and time taken to make a decision. Then we moved, once that first phase of the project was operational, we then moved to the second phase where we looked at building what if scenario modeling on top of the first principle models by the simulation software. When we dwell deep into that, what we figured out is that there are two issues up there. So first was to practically operate a simulation model, the operator has to sit and input a series of parameters into that model. It was taking too much time to enter this data into the simulation systems. And it was a cumbersome process to run the simulation models. So our first question was, okay, how we can ease this kind of data input? So what we did was we created an interface which will take data directly from historians and Cerebra data platform to the simulation software, and thereby reducing the manual input that was required for the operators to run the simulation model. That brought out a lot of process efficiency. And the second phase was to build an ML layer on top of it using artificial neural networks to enhance the prediction accuracy of the models for the what-if scenarios. The one more additional thing that we did was to compare the accuracy of a machine learning model against a first principle model so that operators can trust the machine learning model before they make any decision which is high impact on the ground. So just to go into the details of what we were able to deliver in terms of annualized benefit, I think most of our customers and prospects, when we talk to them, most of them have got real worries about what's the perceived value or ROI from a machine learning kind of a project. So when we looked at the results that we were able to deliver to our customers, we reduced the production deferments by 8 to 12% across the network. This is about the accuracy of the decision making that I was talking about, which prevented the revenue loss for our customers. The second was enhanced decision support. By layering a ML model on top of your simulation models, we were able to achieve better accuracy while taking these what if decisions, which is high impact across the gas network. The third one was we were able to enhance the productivity of the field personnel who was running the simulation models and inputting the data. We reduced that to 5 to 10 minutes. And we were able to create some enhancements like a scenario journal, which can be used across multiple field engineers. One time you create a scenario, you can save it and you can rerun it without any kind of additional effort. So we were able to drive this project with a 10x kind of an ROI and the payback period within less than 6 months' time. Okay. I know there will be a lot of questions around the ROI and the way we approach the project, but I'll pause for Swati to roll out probably the last poll question. Swati?
So I see it's live. So again, if you guys go to polls with the red dots, you can vote again on the new poll. Yeah, I see the responses coming in.
Wow, I think overwhelming 71% feels that they're going to increase the spend in digital technologies. Swati, can we Okay. Okay. Good. So I think I just want to leave you with this thought. Okay. Like any other transformation that you go through, personal, professional, or even at the organizations, the best time to embark on this journey was yesterday. And the next best time, which is available for now, is now. Okay. So with that, I'll leave the floor open for the questions. So I've seen a few of that coming up through the chat.
Okay. Yeah, first of all, thank you so much for that presentation. And indeed, I see quite a few questions in the chat box. So I'm going to go through them chronologically, and I see Paulus has been quite active on them. So the first one is, are your algorithms mostly black box, so solely based on data trends, or white box, so with knowledge of the underlying physics?
Yeah. Paul, this is a very, very insightful question. Okay. Most of these discussions around ML models revolve around this concept of a black box, where it's very difficult to draw a cause-effect conclusion from the model. Okay. But if you look at our industry, particularly oil and gas, process chemicals, we base our industry on strong basis of physics, thermodynamics, engineering principles. Okay. So what we intend to do in most of our, in almost all our algorithms is that it's not the sophistication of algorithm that matters. It's about the elegance and simplicity on how we can communicate that cause and effect to an engineer, and how we can rationalize to his engineering mind that why we are suggesting a certain action on the ground. So most of our models that we prepare are like our white box, so that we gain trust with our operators, so that we can explain the cost effect to him before he makes a decision on the ground based on the models. So the short and sweet answer is yes, our bias is towards white box models that are explainable to the user.
Great, thanks so much for that answer. And I think it links pretty much to the second question from Paulus as well, where he said, okay, I'm hearing about first principles, which implies a study has to be made of the actual system, correct? Just to clarify.
Yeah, so when we refer to first principle, see, for example, in these conditions, when a field is being developed, the reservoir team, the field development team, and the production team sit together and makes the plan for that field in terms of where the well has to be built, what will be the expected production, what are the pressure, temperature, and flow that is expected. These all go into their field planning exercise. And based on that, they configure or they build this gathering system network, size the equipment required for that, what kind of processing is required. So that's what we call as the first principle. So this first principle knowledge is encapsulated either in your simulation models or your flow nodal software that is available. So we take that input and enhance it by an ML. So I just want to leave you with this thought, Paul. We don't think data analytics or AI or ML is the only lens to view an operating context. It is just one of the lenses that you can use in conjunction with your physics thermodynamic models. So we are not evangelizing for one model, one viewpoint. We think that this is a complex operating context, so you need as many lenses to understand the context to provide a useful insight to our users.
Great, thank you so much for that. And I hope that answered that question, Paulus. And I see Paulus actually asked a third one, which goes into the time you guys spent at Flutura. So how much time did you take your team to develop, introduce, train, fine-tune, and so on this model? So maybe you can give us some insight into that.
Yeah, so this project actually we completed in 5 months' time. bulk of the time was spent on making that data available for analysis. Okay. Strangely, in our industry, we have a lot of data silos, proprietary data platforms. Either you look at SCADA or Historian. They all use their proprietary data format. And to bring it up to a common place so that you can triangulate, you can bring an operating data plus a maintenance data from your compressor maintenance history. That's a huge challenge because data resides in silos. So once we get that on board with a sufficient amount of historical data, we were able to pull through this project in 5 months' time. But if you look at it about the fine-tuning and enhancement of the models, that's an ongoing process. So just think of these models as a beast that you feed with data on a real-time basis. So every piece of data that flows through this model is going to enhance this model and retune the model. So tuning of this model is like it's like an ongoing effort, which is done almost automatically. So to come back to the question, so it took us end-to-end 5 months. A lot of that would have been saved with a good data structure and a ease of connectivity available for us.
Okay, great. Thanks. It's quite some time, but now the product is here. And the question I might have is then, so now it's there, but if I'm the manager and I would like to actually use the platform, right, and embark on this digital journey with data analytics and AI, how do I plan for this? Where do I start?
Yeah, so Nico, this is a classic question that we hear from most of our prospects. Almost everyone have a great ambition and a goal for digitizing their business, but it's a jungle out there. So you need a map to go through that journey. So what we force them to think is along 2 dimensions. What is a perceived ROI? So this is a question around why. Okay, why do you want to do this? Okay, if you have a clear why that is stated, then how is easy. So we want them to force their thinking around the perceived ROI that they want to gain. The second dimension that we ask them to think through is what's the readiness of your organization to go through this journey. So the readiness can be further broken down into data readiness. Do you have data? Do you collect data? Second is about your technology readiness. Do you have a required toolkit to make sense of the data? And third is about the culture readiness. Do you have a culture of basing your decisions based on data? Or do you need a culture change? So when you think from a perceived ROI and an organizational readiness basis, that clearly breaks your jungle into 4 quadrants. Say there are use cases that have high or low ROI perceived. And we normally don't ask them to look at a journey where you have to think through about a low ROI use cases. But we focus on high ROI use cases. And we pick where readiness is high, which will bring some kind of a winning momentum within the organization. So we time box the projects for less than 3 months kind of a time box. Because success is a force multiplier in any organization. So if you see success that is coming in less than 3 months' time, that actually accelerates the journey and creates a flywheel effect within the organization. So we ask them to take on projects which has got a higher ROI, high readiness, before we go and tackle real serious problems with high ROI and low readiness.
Okay, great. I think that was quite clear to me. I hope it was also an interesting one for the group here. I see we don't have any other questions. I think this would be my last call for anybody to ask a question, raise a comment if there's something unclear or something they would like to put out there. And maybe one last question. I see we're running a bit over time, but one question which also interests me, it's slightly different, is so every software provider, also you are talking about these digital twins. Could you explain what that is and how is Cerebra's digital twin different?
Yeah, it's an important demystification question, Nico.
Yeah,
because this market is full of conversations around digital twin. But our viewpoint about digital twin is slightly different from the whole market's perception about it. Digital twin, for us, the definition will be it's like a digital replication of your physical context. Okay. Like systems, you have equipment, you have processes, you have interactions between different subsystems and units. But market has got, so the way we look at digital twin here in Flutura and within Cerebra is 3 layers. One is we call as a naive digital twin, wherein you just visualize what's happening on the ground. Okay, just the data coming in from the ground visualized on a digital platform. So that we call as step 1, naive twin. The second layer, what we call it as an analytical digital twin, wherein you layer few of the physics-based rules, rule-based diagnostics onto your digital twin, which actually alerts the user about what's the current state of the context. Either it's an equipment or a field that you're looking at. So your rules are layered on top of your visualization. But most of the things that we do in Flutura and with Cerebra is around the third layer, which we call it as a cognitive digital twin, where digital twin can give insights and recommend actions. Okay. So we build a certain level of intelligence on top of your digital twin, where we layer the machine learning models as well as your physics-based models on top of your digital twin, and the data is streamed into the digital twin, so that the digital twin can execute these models on a real-time basis and suggest actions. So that's where we see most of our effort focused on. If you look at the case study that we looked at today, it focuses on this cognitive digital twin rather than a naive digital twin, which just showcases some data. I hope that differentiation is clear.
Yeah, thank you very much. I'm going to allow myself to jump back on here on the screen because I think we've reached the end here. At least my questions are answered. Thank you so much for answering these two. I think it was a very interesting presentation. Thank you also for raising the questions in the chat box. Thank you everybody for tuning in. I think we've reached pretty much the end here. Apologies for running a bit longer, but I think the explanations were just very, very intriguing, very interesting. So I think everybody is fine with that. And of course, the video will be uploaded. It can be shared later on. We will reach out to everybody who has registered and is also here. And it will also be attached on the platform itself on TechnologyCatalogue.com. You can find all the infos there. And I think I would just want to say thank you for presenting today, Hamish.
Thank you very much. Thanks, Nico. Thank you, everyone.
And exactly. Thank you, everybody, for tuning in. Stay safe, stay healthy wherever you are in the world. I wish you, depending on the time zone, a great day or remainder of it. And I hope to see you for the next webinar sometime soon. And all the best to you with Flutura. And thank you, everybody.
Thank you. Bye-bye. Thank you very much. Bye.